We're going to set you on fire too. All right, so let me do some damage control first. On problem number 3, on the day 3 homework, a lot of you told me the answer is no solution. Okay. Not possible. It's real simple. If Zara's on fire, she's only got 2 options. She's either a distance away from the river or she's in the river. Does that make logical sense? Right. No solution would imply she just ceases to exist in the problem. Okay? In other words, there must be some distance that she's going to run to the river. That, again, we said is along a perpendicular. What happened to my perpendicular? There it is. Okay? No solutions implies that you don't understand what you're doing. Okay? The only answers for D are some numerical distance or 0. If it's 0, she's starting the problem inside the river, which is ridiculous and probably won't happen because that's not much of a problem. Are you with me? This would be the audience participation part of the program? Yes. Excellent. Okay, so let me ask you a question. Let's say we've done the work already, and the equation of the river is, I don't know, whatever. Negative 5x minus 11. Okay? And I tell you that Zara is located at, how old are you? 15. And what day of the month were you born? The 4th. Oh, that's perfect. Okay. She's located at 15.4. Before I even dive into the problem, I have a simple question. Is she in the river? How do you know? Don't trust my picture. I'm just asking you a simple question. How do we know that she is or isn't in the river? Ellen? Anybody else? You know, are you talking? What'd you say? Too much work. It's easier than that. Yes, you do. Yeah. I can tell you for a fact she is not in the river. How do I know that?
Is she in the water? Or in between the thing?
You're trusting the picture. Assume that my picture might not be accurate. She very well might be right here. How do I know if she's on that line? Let's ignore the fire and river thing. Let's just ask a simple question. I'm wondering, is Z on the blue line? And I've already told you the answer, no. But the question is, how do I know that? Because
you can plug it in.
Bingo. Plug it in. 4 equals negative 5 times 15 minus, why is things disappearing? 5 times 50 says negative 75 minus 11. And I'm wondering, does that equal 4? Well, that's, last time I checked, 4 does not equal negative 86. Well done. Everybody with me? Great. So I would like to start the problem then by putting Zara in the river. Let's call this point Z1. Where is Z1 in order for the problem to start with her in the river? By the way, there are an infinite number of answers to the question I just asked you. All I'm looking for is one possible solution. Let's do some erasing here. Get rid of this. Let's get rid of this. We don't need this anymore. Okay. Mark?
So I think I know the coordinates for Z1. So it could possibly be 2 1/5, or let's just say 11/5, and Z. So 11/5 is Z0.
You're giving me a possible location.
Yes, possible.
11/5, comma 0.
Yes.
No. You're close. You made one small mistake. Look at the problem and tell me what your mistake is, Mark.
Oh, negative.
Perfect. One possible location is that she could be at negative 11/5, comma 0. I don't like fractions though, Mark. Could you give me another point where she could be that doesn't involve fractions, because fraction makes me throw up a little bit in my mouth.
Okay. Let's say 2.4.
I don't like decimals either.
Oh.
Right, I'm a whole number kind of guy. Sorry, I'm an integer kind of guy.
Oh, okay. So you do 2, which 2 and 1. I'll deal with them.
Alex?
Is it 0, negative 11?
0, comma negative 11 is also another location. Camille?
You do 2, negative 21.
2, negative 21. Outstanding. Okay, last question before we move on. Zara, what month were you born in?
April.
4th month. 4/4,
No, 4.
right? January, February, March, April, 4th month.
Yeah.
You were born in the 4th of that month.
No, 10.
Didn't you say, or did I ask you? Oh,
I was answering.
oh,
Yeah.
4/10. I thought 4/4 would have been much cooler. Okay, you were born in April, 4th month. Beautiful. Where's she located if she's got an affiliation for the month of April and she decides she wants to start at an x coordinate of 4? What's her y coordinate? Connor?
Negative 31.
Negative 31. Outstanding. Who's confused? Good. Okay. There are an infinite number of points on that river / blue line that we could choose to start the problem. Okay? Any questions? Gavin?
Where the yellow line? Did we move that to Z1?
I just got rid of it. I changed the problem. I used that yellow line to address the fact that the answer can't be no solution. You know.
Show the solve the location.
Correct. Yeah. Just pick an x, whatever x you want. Okay. It could be a fraction. It could be a negative fraction. It could be a positive value. It could be a negative value. You could choose an integer. You could do something crazy like pi, and then calculate what the y value is. Okay. You had a question, Camille?
Oh, no.
Okay. Are we good? Excellent. Okay. So let's move on to what we're going to talk about today. Close this. No. And then open this guy. And we're going on a field trip. A theoretical field trip. I'm not really taking anybody anywhere. I don't want the responsibility. Loading, loading, loading. Okay. Here we go. We are going to go down to downtown Arlington Heights, and we're going to measure the distance between train tracks. I'm going to let you all play on the train tracks. This will be fun. There's no possible lawsuit involved in this whatsoever. Okay. You all have a meter stick in your hand, and we're gonna go play on the train tracks early in the morning when lots of trains come by. If I was to ask you, Nora, catch. Good catch. If I was to ask you, Nora, to go up to that board, there are my train tracks, and draw the path that you would use to measure the distance between the train tracks, could you draw that in, please? Excellent. Could you add something to the picture to make sure I understand that you understand what you're doing is done correctly? What chunk of information would you also need up? I don't know how else to ask you without telling you the answer. What's special about that white segment?
It's straight.
Good. Anything else? No? Mark?
It's perpendicular to the yellow and the
Did you
blue.
intend for it to be perpendicular?
Yeah.
Beautiful. Slap a couple little boxes down in there so we know that. And on the other side too. Okay, good. Thank you. Beautiful. Stick that to the front of the board. Well done. Let's give it up for Nora. Go to your right. Go to your right. Right there. No, right there. There you go. Okay. Do we all agree that that's how you would measure the distance between the train tracks? Right. Okay. Is that logical? You're not going to measure, if I was measuring the distance between the edges of these desks, I'm not going to measure here. I'm going to measure perpendicularly. We're good? Excellent. So Albert is in downtown Arlington Heights, measured the distance between the train tracks. I decide I don't like Arlington Heights, I'd rather be in Palatine. Does it matter? No. Does it matter if Nora drew her white line or white segment there, or higher on the board or lower on the board? No. So that distance should be the same regardless, right? If the distance between the train tracks changes, we've got a big problem. Okay? Because the train tracks are parallel. Today we're just going to do one extra thing. Instead of calculating the distance between a point and a line, we're going to calculate the distance between two parallel lines. Okay, mine happen to be yellow and blue. So if we look at what Nora did here, I'm going to erase this a little bit, even though I had you draw it in there. They're in the way, so I'm just going to do this. Okay. I'm going to use that white segment to calculate the distance between the parallel lines. We'll call it D. And we know, as I said, that those lines are parallel, and we know that D is what we're looking for, and we know that that the white segment is perpendicular to the yellow segment and the blue segment. In other words, Nora's meter stick is perpendicular to the two train tracks. Okay? Any problems? All right, let me give you some information. I happen to know the equation of the train tracks. The blue one is y equals 7x minus 5. And the yellow one is y equals 7x plus 13. How do I know those lines are parallel, other than the fact that I told you that already? Go.
The slope,
What? A little bit more.
the slope is the same.
Beautiful. Okay. Slopes are the same, therefore they are parallel. Hot diggity. Any problems so far? Based on this information, how do I find the length of D? Well, based on this information and what we've already talked about, how do I find the length of D? Stella. Ooh. I'm going to do that. And the only reason I'm going to do that, it's wrong, but the only reason I'm going to do that is because they're all thinking the same thing, and I want to show what happens when you do that. Okay? So a little calculation here. Set them equal to each other. 7x plus 13 is equal to 7x minus 5. Subtract 7x from both sides, we get 13 equals negative 5. Why did that happen? By the way, 13 is not equal to -5. Gavin,
The lines of the axes cancel out each other.
good,
The lines are on top of each other.
good. What am I doing when I set these two equations of lines equal to each other? What am I solving for? More grand than that. What happens when you solve a system between two linear equations, Caitlin? Point of intersection. Why am I getting a false statement here?
They're parallel.
They're parallel and they don't meet. Okay? Thank you, Stella. It's almost like we planned that ahead of time. Okay. Don't do that. Are you raising your hand or are you just spinning your pen around? You got an idea?
Yeah,
Oh, share it.
well, you find the, what's the
I don't know.
word? The slope is perpendicular to 7.
Oh, so you know the slope, you know the slope of the white segment.
Yeah, it's perpendicular to
Okay, that's a good place to start. What's the slope of that white segment?
a negative 1 side.
I like that. Okay, it's a good start. It's better than nothing. Other ideas? Hey,
We can plug two numbers into the x and y and then solve for both of them. And then that would give us 2 points, and then we find distance between the 2 points.
ooh, I think I like where you're going with that, but be more specific.
Because they're parallel,
Yeah.
no matter where the 2 points are. Wait, how do I? But the line wouldn't be straight though, would it? If we
All lines are straight.
they wouldn't be perpendicular.
All right, well, we can play with that a little bit, I think. Okay.
You could, like what he said, because the distance is gonna be the same between them, no matter what.
Okay,
So if you.
so where are we gonna put Nora? Where did you wanna measure you wanna be in Arlington Heights, Mount Prospect, Palatine, Des Plaines? What's your preference?
Arlington Heights.
You like Arlington Heights. Do you live in Arlington Heights? No, but you wanna be in Arlington Heights. Okay, right there by the train station? Okay, good. So, does that help? How?
Because, well, it provides a specific location.
Okay, here's a specific location. Where are you, Nora? We'll call that point N. You're in Arlington Heights, right? Great. Is that going to help us solve a geometric problem? No, so we need more information. Yeah.
What if we find like the middle of the line and then?
You can't find the middle of the line. Lines go on forever and ever. You can't fold infinity in half. You'll cause a rip in the space-time continuum, killing everyone in the universe. What do you want?
What if you put 2 points on the yellow line and the blue line and then solve the intercept for D on the yellow line and solve the intercept
Huh.
on D on the blue line? And
Can I repeat back what you said just to make sure I understand what you're saying? You're saying pick a point on the yellow line, pick a point on the blue line. No, don't do that. Pick a point on the yellow line. I did, N.
well, I mean like 2 points that
2 coordinates you're talking about. Oh, all right, hold on, let me get back to you in a second. Nora, what coordinates would you like for your location?
6, 4.
Is 6'4", my voice just cracked. I'm getting puberty. Is 6'4" on the yellow line?
Actually,
You want to change your answer? You think
57.
6, 57?
Isn't that what it is?
You sure 57? Wouldn't it be 52? Right? How'd I get that? Do we all agree that 6'4" is not on the line?
Yes.
Yes, because if I plug 6 in, I don't get 4. However, Nora is changing her answer to
55.
55. 6 comma 54. um, do, do you want to stay there or move? Oh, well, you don't have to. This is America. If I power right on, you can stay there, and we can solve the problem this way. I got no problem. I mean, you got calculators. Who cares how big the numbers get? Or do you want to move? What town are we going to?
Mount Prospect.
Mount Prospect. Okay, down the road a little bit. To what location?
120.
1 comma 20. Is that good? Is that point on the yellow line? Yeah, because 1 times 7 is 7 plus 13 is 20. Okay, good. All right, Zach, back to you. Hold on, Una. So we found out where Nora's starting. She's in Mount Prospect with her meter stick at the location 1 comma 20. Now what? It's not a good way to start an answer. Start over.
I thought like you put 2 points, like 2 points around the intersect of the line on yellow, and then you solve it like we did on the other problem, and then do it on the other side to find the intersection.
So you want to relate this train track problem to, who was it we set on fire originally? Bryn, was that you? Okay, so you want to turn the train tracks problem into a bring on fire problem?
Yeah.
Huh. Interesting. So if I do that, isn't that the same problem that we did the other day, I meant?
Yeah.
Okay. Whoops, wrong button. Perpendicular. Yes?
How do we know that 120 is on that thing?
Great question. My friend Nora will answer that.
Because if you plug in 1 and you like solve.
She chose the point. Well, she originally chose 6. Any particular reason you chose 6? No, she just fired off a random number 6, and then she realized if she used 6, it would be 55, and we get afraid of big numbers, so she dialed it back a little bit to 1 comma 20. She could have picked anything for X. What day of the month were you born on?
22nd.
She could have chose 22 for X, and then we would have had 154, 167. That would have been ugly. We don't want to do that. Okay. Is everybody with me so far? I took the train track problem, and with a couple people's help, I turned it into the same problem we were looking for yesterday. Now, what's the equation of the white segment? Camille, question or answer?
Answer.
Go.
Y minus 20 equals -1/7 parentheses x minus 1.
Beautiful. Let's call this point T. How do we find point T now? Go.
You find the point of that intersection.
Yeah, beautiful. Like we said earlier, solving a system of equations gives us the point of intersection. Now this becomes a system. Okay, go ahead, solve the system. I'll wait. Do 2 things. Oh, wait, hold on a second. Let me explain something that's going to mind scramble some of you. This problem that we started with the train tracks, has an infinite number of ways to solve it. I know. So, if we go back to this problem and start over again, everybody can do the problem differently. The only thing that'll be true for all of you is this value here. So let's review. When we had the train tracks, Nora decided she wanted to start in Arlington Heights at the point 6 comma 55. And that was too ugly, so she moved to Mount Prospect. And she chose the point 120. There are 30 of you in this room. That's 30 different locations. Maybe Grace goes to Park Ridge and she chooses the point 0 comma 13. Maybe Una goes all the way down to Woodstock and chooses the point -10 comma 57, -57, something like that. Okay. Everybody can solve it differently. The only thing that's going to be the same is your answer for D. So not only do I want you to solve that system, and here we're going to cheat because you all need the same answers, but then take it further and figure out what D is. D is the thing that matters, the distance between the train tracks. Okay, go.
Already.
Hello, Daniel. Let me show you what happened. You mistook the last problem as a related rates problem. So this is not a related rates problem, so you have to decide.
Do you guys have like big fractions?
Here's a desk for you to sit at. Yep. Can I talk while you're working? Good. Let me rephrase my question. Will you all listen to me if I talk while you're working?
Yes.
It's kind of a gray area there. I know I continue to hype on this, and I've been hyping on this for like 11 weeks now, but understanding what you're doing will make your life so much easier. For those of you that just are trying to memorize a system or an algorithm to solve these problems, that kind of goes in the crapper now, because there are an infinite number of ways to solve this problem. Understanding what you're doing is going to allow you to breeze through these problems. Okay, so I would encourage you to understand why you're doing the things you're doing, not just memorizing, and now I do this. Okay, thank you. Carry on. Does that mean they don't know if you were targeted or they don't know if you were targeted? They don't care.
I got it.
You got that. I got one.
Who's coming next? Today.
Nice solve. I divided right out. I got 134 and
No, but I believe I went to my 7 or
Oh my gosh. Well, they're gonna hate you for this. And I'm gonna blame you.
For what?
oh, I did not.
and then on PS4, so negative 177. Okay.
Oh my gosh.
Hold on 1 second. Hey, Nora, what'd you get for X?
88 over 25.
Yeah, it's 8. I was like that. I was like
Anybody else get 88 over 25 for X? Yes? Yeah? Okay, we're gonna go with it.
Reedy, I get calculator, right?
Oh, sure. Okay, stop what you're doing for a second. You'll notice I'm not going to solve that system. As I mentioned the other day, this algebra you need to be able to do at this point in time. So solving systems, the assumption is that you can do that. Use your calculator as much as possible. Okay, in other words, when you're converting that to y or to slope-intercept form, which is what a lot of you do, you want to write the White equation as y equals blah blah blah. You don't have to take 1/7 and add it to 20. Use your calculator to do it. Okay. By the way, what's the y value, Nora?
491 over 25.
That's a pretty ugly answer. Now, maybe if we went back to her original answer, or her original location of 6,55, maybe the values for x and y would have been nicer. But again, we don't care because we've got a calculator. If we were doing this without the distance formula, I would have to do it in a completely different way because I wouldn't expect you to find the distance using those ugly numbers. But we're using the tools at hand, so therefore, you don't care how ugly it gets. And that's why I do these random problems. I'm not coming in with this pre-baked answer or problem where you're going to get a nice pretty answer like 1,3. That's boring. Right? Did you guys finish the problem? What'd you get for D?
2.546.
2.546. All good? Just leave it there. Thanks.
Thanks, Reed.
Now again, no problem, Daniel. I mean, is that a realistic answer? Well, we don't know units. I know it's not feet. A train track is more than 2.5 feet apart. I know it's not meters because train tracks. So this was a randomly generated problem. If it was a real case scenario, then I would engineer the problem to fit a real train tracks measure, but I don't care. All right, any questions on that? So again, let me reiterate. If this value changes, Nora decides to go somewhere else. If that changes, then this is going to change. So when you're working on these problems, and you're working with your group, if you choose different starting points, you're going to have different x and y values. However, when everything is said and done, your D value has to be the same. The distance between the train tracks has to be the same everywhere along the train tracks. Okay? I took the problem from, today's Wednesday, from Monday, and I turned it into a stupid problem of setting Bryn on fire. Hopefully that helps you understand what you're doing algebraically. We took a simple parallel lines problem and turned it into a train tracks problem, and hopefully that helps you understand what you're doing, not just blindly memorizing the algorithm for solving. Okay? And last thing I will say is, remember what we did in order to get to this problem. Okay? Nora chose where she wanted to start the problem, and then it became a problem just like Monday. Okay? Any questions? We're good? Beautiful. Okay, give me 1 second here. Exit.